Hello students, this is Professor Chalai, and in this video we're going to look at gravimetric analysis. As always, you can follow along with our Chapter 4 workbook. By the end of this video, you should be able to use mass to analyze the different components of a reaction. Why? Because that's what gravimetric analysis is. So gravimetric analysis has a similar root word to the word gravity, and so basically it's using mass to analyze components of a reaction. And we've done a lot of calculations using masses to analyze components of reactions, the different substances in a reaction. And so number 32, let's just add this here, find the percent yield. Number 2 is a calculation that you've done a number of times already. It's just finding the percent yield given the mass of a starting mixture and the mass of a product. Now, I'll leave you to do this one by yourself. I'll put the answer here, so you can pause the video now. And if you have the answer, the answer that I came up with was 71.49% to 4 significant figures, and hopefully you got the same thing. But this is gravimetric analysis in a sense because we're dealing with masses of different components of the reaction mixture. Okay, with that in mind, let's try to work out number 33 by yourself. It's a little bit of a different problem, but I think you have all the tools that you need to try to be able to figure this one out. If you can't, on pause, and I'll give you clues to help you along the way. Okay, so hopefully you figured this out. If not, let's just examine this question a little bit closely. We have some sample of material that is 1.1324 grams. From that, we reacted with excess silver plus. So this sample contains chloride ions and other things. We reacted with excess silver plus to give us silver chloride, and the mass of silver chloride was 1.0881 grams. So, in other words, we have excess silver chloride, so excess silver from, let's say, I don't know, maybe silver nitrate, aqueous, reacting with some compound with chloride. So we'll call this, I don't know, we'll leave that blank. So some compound with chloride to give us silver chloride, solid, plus other stuff. So it will be let's say the anion from our silver plus the cation from the chloride, which we don't know what it is. So other things. This here is just a net ionic equation. Everything else are spectator ions. So we know what our mass of this guy is. It's 1.0881 grams. We know what the total mass of this compound is, right? It's 1.1324 grams. And the question is, what is the percent chloride in this sample? So what is the percent of chloride by mass in this sample? So hopefully that gives you a clue. Try to work it now. If not, you can unpause and I'll give you more clues. Okay, so this is the opposite, if you think about it, the opposite of a theoretical yield calculation. Here we have our product, the amount of product we have. We know that for every 1 silver chloride, every 1 mole of silver chloride will have 1 mole of chloride. So we could use that to find the moles of chloride and then the mass of chloride. And then if we know the mass of chloride and the mass of the whole compound, which is right here, we can find the percent of chloride in that compound. So pause the video again and try to figure that out based off of that explanation. Okay, so let's work this out. We start with 1.0881 grams of product, silver chloride, which we can use to find the moles of product. So we divide by the molar mass of silver chloride, which is 143.32 grams. Hang on, let me just create a little bit of space here so that I can write the names of these compounds. So this would be AgCl. And so it's 143.32 grams of AgCl per mole of AgCl. There we go. Now that we have moles of silver chloride, we can convert that to moles of chloride. So 1 mole of silver chloride gives it is formed from 1 mole of chloride based off of this equation right here. Now that we have moles of chloride, we can find the mass of chloride. So the mass of chloride, to get that, we just multiply by the molar mass of chlorine, which is 35.45 grams of chlorine per mole of chlorine. So if we plug all of this into our calculator, we get that the mass of chlorine atoms that we started with must have been 0.2691 grams of chlorine. So that's the mass of chlorine, and the mass of the entire sample was 1.1324. So the percent of chlorine would be 0.2691 grams divided by 1.1324 grams times 100%. You plug that into your calculator and you will get 23.77% chlorine. So here's just an example of such a problem. Now, using this, other researchers can be able to use that to sort of figure out, well, what was this compound that we started with? It has 23.77% chlorine. So that's just another way that we can use gravimetric analysis. It's not only to find percent yields and things like that. Sometimes we can use it to find what unknown compounds are in our solution. All right, that will bring us to the end of this video. In our next video, we'll continue with solution stoichiometry. I'll see you then. Bye.